Hey guys, it's Mr. Brian here. In this video, I'm partnering with EduKaji to guide you on the SPM 2023 physics paper, and we'll be discussing paper 1 today on your 40 objective questions. Right? Without further ado, we'll get right started. Okay, so this is our 2023 physics paper, 1 hour, 15 minutes, paper 1. Let's start with question 1 straight. The information below shows the speed and direction of an aeroplane. An aeroplane moves at a uniform speed, 60 km per hour to the west. Which of the following combination of quantities are found in the statement above? Right. So there are a couple of things because they mention speed. So definitely it has to be derived quantity. It cannot be base. Yeah. So P is definitely out of the question because base it has to be like length, it has to be mass, time, or this very simple one. You know you only have your 7 base quantities. Yeah. Um, derived meaning it is derived from distance over time. Okay, I don't think derived quantity is the problem here. The problem for a lot of students is on the scalar and vector quantity, on whether it is magnitude only or does it also have a direction. Yeah, if you see the word speed, then you would think scalar quantity. If you see velocity, then you would think vector quantity. But you have to be careful because they mention to the west. So this is what we mean by the magnitude. 600 is the magnitude. The magnitude meaning the value. To the west is the direction. You get what I mean? There's magnitude, there's direction. This is a vector quantity. So answer is Q and S, donkey. Okay, so be careful, even though they use the word speed, but then they give the direction at the back there. Yeah. Okay. Question 2. Diagram 1 shows a man running in a circular path with a perimeter of 400 meters and a radius of 63.6 meters. Okay, there's a little error in this picture. It's meters, not cm. After 10 minutes, he reached half of the circular path. What is the man's displacement at the time? So I believe he's going to run, and 10 minutes later, he will reach half of the circular path, meaning here. Okay, so displacement, don't forget, means the shortest distance. If you overthink it and you go and think, oh, teacher, do I need to go and find out what is the length of this arc and all that? Don't need. You're overthinking it. I don't need to find this. This is called distance. Okay, if I want displacement, it will just be from here all the way to here. The shortest distance from the starting to the end point. This is your end point, which means I want the diameter. I want 63.6 meter times 2. Okay, and that sounds like 127.2, 63.6 times 2. Yeah, 127.2. Answer point. Okay. Question 3. Diagram 2 shows a parachutist is preparing to land. Which of the following is a safer landing method? Okay, which one is the safest to land? Spread the arms to increase stability. Okay lah, KIV lah, this one. I don't think it helps with landing, yeah, but usually spreading the arms will help you to lower your center of mass. Let's say if you're trying to balance on a beam or something, then maybe it will help. But I don't think so. This helps. Okay, but let's see if there's any other answer. Bend the knees to reduce impulsive force. Okay, I think this one is one of the best answers so far. Spread legs. This one definitely wrong. Sounds a bit weird. Lay the body down to reduce pressure. No, if you lay your body down, you have no control. With your feet knows how to land and knows how to bend and all that. If you lie on your back, you're not gonna land properly. Yeah. Answer is boy lah. Because bending your knees is what we call soft landing. And soft landing will help you to reduce impulsive force since when you bend your knees, right, it's like you are falling for a longer time. You don't just fall straight. You hit the floor and you continue falling because your knees are bent. This will increase the impact time and reduce the impulsive force. Answers boy. Okay, soft landing. So it won't hurt your knees. Huh? Diagram 3. Question 4. Diagram 3 shows two rugby players running towards each other. Player X and Y runs at a speed of 8 meter per second and 10 meter per second, respectively. They're running towards each other, so towards each other. Both players, they have the same mass. Okay. Which of the following is correct when both players collide each other and fall together? They will collide and then they will fall together. Okay, let's take a look. A, momentum of player Y is equals to momentum of player X. Nope, because Y, they have the same mass, question said. But then their velocity different, no? So if you take momentum, which is mass multiply velocity, it will give you different answer. So they don't have the same momentum. Huh? The collision occurred is an elastic collision. Also wrong. Because they say they will fall together. Question say they'll hit and then they'll fall down together. Falling together means it will not hit and bounce off. Hit and bounce is elastic, like a rubber band, very bouncy, or like a spring. I think it is inelastic. They'll hit and then fall together, same side. Huh? Okay, but let's look at D also. Total momentum after collision is greater than total momentum before collision. This is definitely wrong. Remember our principle of conservation of momentum states that the total momentum before you collide must be equal to the total momentum after you collide. Yeah, of course, provided there is no external force acting on the system. Sorry, I wanted to circle C. Answer C, not D. So question 4 is C. Can the rest are all wrong. Okay, the keyword is fall together. Okay, the keyword is fall together, inelastic. Number 5, the relationship between force, mass, and acceleration is given by this equation. Which of the following represents this equation? Okay, this is Newton's second law of motion. If I ask you, what is the first law about? You need to know. First law is about inertia. Newton said, for Newton said, if an object is at rest, it will continue to stay at rest. If an object is at constant velocity, it will keep on maintaining a constant velocity unless somebody go and disturb me, unless there's an external force, or else I'll keep maintaining my same motion. That's inertia, first law. Second law is all about F equals to ma. Okay. Third law is about action and reaction. For every action, there is an equal but opposite reaction. Usually talking about impulsive force or explosion. Okay, so if you don't know, in your textbook, Newton's third law is when you learn about impulsive force also. We're saying like, if you punch somebody, let's say you punch somebody, you have an action, there's going to be a reaction on your hand also. If you punch with 10 Newton, you will feel a reaction on 10 Newton onto your own hand. That's kind of like that. Yeah. So every action got reaction. Impulsive force. Explosion. Why so specifically explosion only? One very good example is when you fire a gun or when you launch a rocket, right? You know that when you launch a rocket, exhaust gas shoot out, there's action, and then as a result, the rocket is going to fly forward. Action from the exhaust shooting to the back, reaction of the rocket flying forward. Action and reaction. Gun also the same. You shoot the bullet out, the gun will move back. Action, reaction. Okay, bullet go to the front, the pistol, the gun will move to the back. Action and reaction. Okay, so usually impulsive force explosion, third law. Can. Question 6. A metal spoon is placed inside a hot coffee. Which of the following is correct about the heat flow? The heat flows from the coffee to the spoon only. Nope. Net heat flow is from spoon to coffee. Nope. Why? Hot coffee is the hotter object. Spoon is the colder one. When we say net heat flows, we are talking about majority of heat flow. You must remember, between two objects in thermal contact, spoon, coffee, heat will always transfer between the two. Okay, between the two. And majority of the heat flow is always from hotter to colder object. there's a lot of heat flow from hot to cold and less heat flow from cold to hot. Okay, so mostly it's hot coffee, coffee, water to spoon. Okay, so B also wrong. Let's see C. There is no heat flow from both coffee, water, and spoon at thermal equilibrium. Also wrong. The rate of heat flow is the rate of heat flow from coffee, water to spoon is higher than spoon to coffee, water. Yeah, answer is donkey. So imagine like this, there is object A and object B. Okay, I'm very bad at drawing a spoon and a coffee, so I don't bother. I just draw A and B, object A and B. I want you all to think, one guy is hotter, okay? Let's say the coffee. One guy is colder, let's say the spoon. There's majority of heat transfer goes this way, let's say 50 joules. And then there's a little bit of heat transfer from cold to hot also, maybe 30 joules. Okay, but we say majority of heat transfer, the net heat transfer. It's like one side 50, one side 30, so they cancel out each other a little bit. The net heat transfer is 20 joules from hot to the cold side. Okay, that's the majority of heat transfer. So please don't say there is no heat loss at thermal equilibrium also, because you know why? Thermal equilibrium, right? Still got heat loss one. Got two object. This to this object, let's say 20 joules. Let's say lah. This to this object also 20 joules. Got heat transfer. It's just that when we total it up, we will say the net heat transfer now at thermal equilibrium is zero. So make sure you understand the difference. There is heat transfer, but the net meaning the total heat transfer will be zero. If you total 20, 20 cancel out each other, you will get a zero. Okay, that is for thermal equilibrium lah. Yeah. Uh, so this one, hot to cold is 50. Is higher than the colder to hotter object, the 30 joules. D is talking about this picture that I drew for you. Okay, Ken? We move on to question 7. So just now question 6, whether or not there is the word net plays a big role. Understand what is the meaning by net. Okay. Number 7, diagram 4 shows a piece of cheese placed on top of a piece of bread baked in an oven. When removed from the oven in a few minutes, it is found that the cheese is hotter than the bread. You take out from the oven. After a few minutes, you leave it there. The cheese is still hotter compared to bread. So bread already cooled down, cheese still very hot. Yeah. Okay, which of the following statements is true? Cheese absorbs more heat. Cheese absorbs more heat. I think so. I think cheese can absorb more heat, but let's look at the other answers also. Cheese has higher specific heat capacity. This one confirmed correct. Why? The reason why cheese can stay very hot for a long time is because cheese takes long time to cool down. And I always tell my students, you remember this way. If cheese takes longer time to cool down, it also means it has a bigger specific heat capacity. The word capacity in English means capacity means a very big volume, a very big tank. You have such a big tank that you can store a lot of heat. It can absorb a lot of heat. And imagine one tank full will increase by 1 degree Celsius. If you fill up one tank, then you increase by 1 degree Celsius. So the cheese can absorb a lot of heat to increase 1 degree Celsius. Absorb a lot of heat, increase. When it is in the oven, it was able to absorb more heat because the tank is very big. The capacity is very big. That's why I say number 1 is also most likely correct. Okay, big capacity, which also means cheese is normally anything that take long time to heat up, uh, take slower to cool down, slower to heat up. All these are usually quite good insulators. Normally those things that very fast one, take very short time to heat up, take very short time to cool down. Small t means a smaller capacity value. It's a very good conductor usually. They're very fast, shorter time. Okay, this one is extra info lah, right? But back to the cheese and bread. Cheese and bread have same specific heat capacity. Okay, definitely wrong. Specific heat capacity of cheese is lower. Also confirm wrong. Okay, the only correct answer has to be 1 and 2. Answer is A, yeah? For question 7. Okay, yeah. Still hotter, meaning very slow. You use the word slow to remind you. Slow means take very long. Very long means big C. If take short time, that means the C value is small. Okay. Question 8. The gravitational force of the Earth on the moon is this. Earth on the moon. Okay. What is the gravitational force of the moon on Earth? Answer is A. Okay, answer is A. This one, they just want you to know that gravitational force is mutual. If you are standing on Earth, let's say, I hope you know that yes, the Earth is pulling you, maybe with some force of, let's say, 700 newtons. Let's say the Earth is pulling you 700 newtons. But please also know that you are pulling the Earth 700 newtons also. It works both ways. It's an attraction force. Same thing lah, Earth and Moon also the same. Any two objects will experience this universal force that is always mutual. You pull me 700, I also pull you 700. But how come I cannot move the Earth? The, the Earth will always pull me down. But why I cannot pull the Earth up? Because common sense. 700 Newton is enough to pull a human down, but 700 Newtons is not enough to pull the very, very heavy Earth. You get what I mean? So, but you need to know you are pulling equally like that. Yeah. Okay. Question 9. The diagram shows a rocket with a high velocity to overcome Earth's gravitational force. Okay. Which of the following statement is true? To overcome Earth's gravitational force. It sounds like we are trying to escape. Right? Sounds like it is trying to achieve escape velocity. Okay, which of the following statement is true? Velocity of rocket equals to escape velocity. I think this is true. Velocity of rocket is equals to linear speed. Okay, cannot. If it's equals to the linear speed, you cannot escape. Linear speed is the speed you need to orbit round and round in circle. To make sure you go round and round in circle, this one is called linear speed. But question say, I want to escape. Yeah, I want to overcome Earth's gravity. I want to escape. Okay, anything linear speed is wrong. And then C, velocity of rocket is less than escape velocity. If less than the escape velocity, you cannot escape. Right? Answer has to be A. As long as you can equal, you don't have to be greater even. As long as you can equal, you can achieve this, then you can escape already. The definition of escape velocity is the minimum velocity needed by an object on the surface of the Earth to escape to outer space by overcoming Earth's gravitational force. Yeah, the minimum value. If you achieve the minimum value, you can escape. You can equal to this, then can escape already. Even if it's not greater, it's fine. You can still escape. Okay. Question 10. Diagram 6 shows a displacement time graph of a wave. Which of the following physical quantities can be obtained from the graph? This is 5.1, your graph basics. I always tell my students, whenever you have the x-axis and y-axis like this, just know the time here you can use to go and find the time for one wave, which is known as the period. Yeah, the time for one wave, which is the period. So I look at one complete wave and I can see, oh, the period is 1 second. Now 1.00 second. Okay. Displacement. Displacement always means you can go and find the amplitude. The maximum distance from the equilibrium position or from the original position, that is called amplitude. How high can your graph go? And it is equals to 5 cm. Okay, so your wave can go 5 cm up high or 5 cm down low. Okay, answer is amplitude and period, boy. There's another kind of graph lah. Sometimes they can also give you, another one is displacement and distance. If it's displacement distance, what can you get from distance is the wavelength. Okay, the distance for one wave. Yeah, the distance for one wave and the time for one wave. So time then is period, distance then is wavelength. Okay, yeah. Okay, question 11. Which of the following factors can reduce the frequency of oscillation? Okay. Reduce frequency, that means frequency means how many times can you oscillate in 1 second. Yeah, so you want it to oscillate less number of times in 1 second. There are still, if you increase the length, if I increase the length, I think it will take longer time to swing over and come back. It will take a longer time. In 1 second, there's going to be less complete oscillations. Frequency is how many times can you oscillate in 1 second? If it takes a longer time, meaning the frequency will be less. Okay, also, maybe you can also take a look at this formula. Sometimes we write it like this, sometimes we write it like that. It is same, okay? It's just that we swap the place. But SPM normally don't give this formula. You need to know this. Frequency and period, they're best friends. Yeah. Whenever you say you want to reduce frequency, it means that you want to find the wave that will give you a longer period. You go and find the one which will take longer time to oscillate. Time taken for one complete oscillation, period, time taken for one complete oscillation is longer. A longer string can do that for sure. Decreasing length of thread, no. If imagine you have a very short pendulum, it's going to swing very, very fast. The period is very, very short. Increasing the mass of pendulum, actually the mass will not affect how fast you oscillate or your time taken to oscillate. Okay. This one is something out of your syllabus a little bit because we never learned the formula for the period and for the frequency of pendulum oscillation. Even though I say mass don't affect, but what affects it is the gravity lah. Yeah, the gravitational acceleration. So on Earth is as long as you use 9.81, you will always be fine. If you go to moon or whatever, different planet, the G value different, then it will affect the value. But mass of pendulum won't affect how long it takes. The length of the string will affect it. Okay, the length of the string will affect it. Okay, that's for pendulum. But for spring is different, huh? For spring, mass will affect. For pendulum, mass don't affect. Okay, this one extra knowledge a little bit, but I think it's good for you all to know as a physics student. Okay, question 12. Diagram 8 shows fringes of yellow light that is formed during a Young's double slit experiment. Let's see what they ask. The distance between the fringe can be reduced by, okay. Please know that whenever I say it is a Young's double slit, it is an interference of wave phenomenon. Okay. And whenever I know it is interference, well, okay, or maybe you might be thinking, teacher, how do you know interference? It's because a double slit means something that has two gaps for the light. You shine a light and then it pass through two gaps, and then it will shine like this, and then they will start to overlap on top of each other. Interference means overlapping, or sometimes they call it superposition of waves. How to reduce distance between the fringes. How to reduce this distance. This distance has a symbol called x. If you go to your formula sheet, wave in SPM usually got two formula only. V equals to F lambda, and this one. This one is the one you use for interference. Lambda equals to AX over D. When you want to reduce distance between fringe, reduce the X value, you can do something like this. I normally tell my students, you go and make X the subject. Meaning you multiply the D, become lambda times D, and then you divide the A come down, times become divide, to make it X. X is always the responding variable. You can go and manipulate your wavelength. You can manipulate the distance D, you can manipulate the slit separation distance, and they will all affect the X value. All these are manipulated variable. X is always the responding. Okay, so to make X smaller, let's see. Replace yellow light to red light. Replace yellow light to, to blue light. Okay, different color lights, all this has something to do with wavelength. Okay, maybe we look at A and B later again. C, decrease distance between double slit. The gap between your two slit, that is called the A. Okay, when you decrease the A, you look at the formula, decrease the A, X will increase. So I don't want. It will increase the X. C is wrong. Huh? Right now we want to reduce the X. Increase the distance between double slit and the screen. From the double slit to your screen, the screen can be like a wall or whatever. That is the distance D. You increase the distance D. Look at the formula here. Increase the D, X will increase again, which I don't want. So answer is A and B. The problem is, if you do not know your rainbow colors, then you cannot answer the question. I normally tell my students, Roy gave birth in Vietnam. Okay, you can have your own way of remembering it, but my way is Roy gave birth in Vietnam. Red, orange, yellow, green, blue, indigo, violet. And red is the longest wavelength. Okay, red is the longest wavelength. So at first they say you got yellow light, remember? If you go and choose red light, you go and choose red color light. Now, red color light is the longest. You go and increase the lambda. What will happen? Increase the lambda means X will increase. Also, I don't want. I think the answer is going to be B already. Yellow color light, you go and make it become blue color light. Remember, on the left, it is longest lambda. If you go to the right side, it is going to be shorter and shorter and shorter. So yellow become blue, it becomes shorter and shorter and shorter. Okay, you make the lambda shorter. What happened? The X will increase. Sorry, the X will decrease. Smaller lambda, smaller X. Smaller lambda, smaller X. Okay, so not easy, yes, this question. But let me tell you something. The answer lies in the formula. Must make use of the formula. Learn how to use the formula. Okay, answer is boy. Can? Okay, can. So must know your rainbow colors. Question 13. Diagram 9 shows part of an interference pattern. S1 and S2 are two coherent sources. Okay, this one looks like a water interference pattern to me, where there are two dippers dipping in the water, and then they create waves. As they create waves, they will overlap. Okay, so your wave is going to have a crest and a trough, crest, trough, crest, trough. Which of the following graph shows correctly the propagation from P to Q? Okay, at point P, it begins with two dotted line overlapping each other. Dotted line is a trough. two dotted line overlap with each other, you're going to get an even lower dotted line. Okay, you're going to get a very low trough. This is a constructive interference. Also, you will start to see a pattern. All these points, they are solid line overlap with solid line. Solid line overlap with solid line. Yeah, all these are constructive interference also. Then here, the orange color ones, dotted line overlap with dotted line. All these dotted line ones, they are, okay, orange color one is like this, huh? Green color one will look like this. Let me show you. Sorry, blue color. The blue color ones will look like that. Okay, but both also constructive interference. It starts with a very low point. I think answer is donkey. Yeah, answer is number 13. Answer should be donkey. Okay, because donkey is the only answer where it starts with dotted line and dotted line. It starts with a very low point, right? And then it's going to go to become very high, a very high crest, and then go all the way down. By the time it reach Q, Q is a point, you see they draw like somewhere in the middle like that, right? It's not if it's the blue color point, it's the very high one. If it's the orange color one, it is the very low graph. It is right between a very high and a very low graph. That is point Q. Yeah, so best answer is donkey. Okay, Ken. Number 14. Which of the following is correct? Your electromagnetic waves, you must make sure you know the order, right? And I always tell my students, you can remember, real money is very useful and extremely good. Real money is very useful and extremely good. Okay, this is how I remember lah. You can have your own way. So looking at this, okay, we got X-ray here, and then we got visible light, we got infrared. Beside the eye is M, right? Between V and X, it is U. Okay, so the Q is your microwave, radio wave, microwave, infrared, visible light, ultraviolet, X-ray, gamma ray. So you have microwave, and then the R is ultraviolet ray. 14 is A. Okay, number 15. Diagram 10 shows an image formed by a convex lens. Which of the following equipment produces an image as above? Okay. We got convex lens, and we are trying to produce an image that is virtual, upright, magnified. Okay, virtual, upright, magnified. I don't think so. Answer is C or B, because usually microscope, telescope, they have two lenses. Okay, normally they have two lenses. And I don't know whether you know this, normally for a normal camera where you take picture from quite far away, usually you are taking picture from quite far away, so therefore the object distance is pretty far. You're going to get a real and inverted and diminished image one. It must be real because you're capturing picture from your camera, phone camera especially, go into your lens, and then it must go inside your phone camera sensor. It must go into your phone, so it has to be real. And I realize a lot of people don't know that the picture that go into your phone camera sensor is always inverted usually. Then your phone will help you to terbalik kan again. Okay, usually it's like that. And then from a big picture you are taking, it goes into your phone, become a small picture, so it's diminished. Yeah, but this is out of the question a little bit. Answer is A lah, magnifying glass. You agree or not? If you use a magnifying glass, you go and read something, the thing that you read will be upright one for sure. Right? You use magnifying glass, your things will not appear terbalik. And it must be bigger. right? It must be bigger. Okay, this is a pretty popular one, magnifying glass. Can I? We move on. Question 16. Diagram 11 shows a diamond that shines when exposed to light. The critical angle of the diamond is 25 degrees. Okay. Which of A, B, C, D shows the correct path of ray after the incident ray passed through point P? Okay. If the incident angle here, by the way, incident angle, you have to measure 90 degree from along this path. So this is your normal line. N is the normal line. They already label for you. And your angle, you must always measure between the normal line and the light ray. So this is your incident angle. If incident angle is bigger than critical angle of 25 degrees, then total internal reflection will happen. But if incident angle is smaller than the critical angle, then light ray refracts out of the diamond. So now the question is, we need to think, do we think this angle is bigger or smaller than 25 degrees? Maybe some students also will ask me, teacher, should we use a protractor to measure this and all that? I don't think so. You need a protractor. You know why? Because you see the angle here, like this is a 90-degree L shape. If you cut the 90 degree into half, this is 45 degree. Right? This is already 45 degrees. So if your incident angle is a bit more than half, definitely this angle will be bigger than 25. Will be bigger than the incident. Total internal reflection will occur for sure. And when total internal reflection occurs, it means that it will reflect inside. Total internal. It happens inside the diamond and reflect. Suddenly, this light ray gets reflected like a mirror inside the diamond. This incident angle and this angle is exactly the same. Any kind of reflection, if the light hit a mirror or anything, any kind of reflection, whether total internal reflection or a normal reflection, the angle go in and come out must always be the same. So answer is C lah. Okay, answer is C. We move on. Question 17. An image with a height of 20 cm. Normally, I like to call that height of image. Is formed on the screen with a distance of 15 cm from the convex lens. The object distance is 7.5 cm. What is the height of the object? Okay. Image with a distance 15 cm from the convex lens sounds like the image distance. V is the image distance. V means image distance. Object distance 7.5. That sounds like U. Some people will say, oh, teacher, got U and V like that. Is it the thin lens formula? 1 over F equals to 1 over U plus 1 over V. No, it is not. If you look at the formula sheet, there is another formula that has U, that involves U and V. Not just this, but this one also. Linear magnification is V over U. But do you also know that magnification you can also find using height of image over height of object? This kind of question is quite popular. Last time in SPM got asked before also. Right, so magnification got two formulas lah. You can go and equal them straight away. 15 over 7.5 equals to height of image is 20 over height of object. Then you can find out the answer. Okay. I don't know how you want to do this. You want to cross multiply and all that also can. But 15 divided by 7.5 is 2 lah. Okay, you can multiply the H and divide the 2. I'm doing very slowly. Answer is 10. Okay, objective lah. So you don't have working also fine. Okay, question 18. Diagram 12 shows image of Ali in the mirror when he stands at a distance less than the focal point. Okay, which of the following types of mirror is correct? Is it a plane mirror, convex, concave, or uneven surface mirror? Plane meaning a flat mirror. Every day you see yourself in a flat mirror, you remember, this one not really in your syllabus, but a flat mirror will always give you a upright image. And it will always give you virtual image also. Because virtual and upright is always together one. If it's virtual, it is always upright. Upright always virtual. If it's real, it is always inverted. Inverted always real. Okay, I hope you at least know that. And it will always be same size. Virtual, upright, same size. When you see yourself in the normal flat mirror, you will not become bigger or smaller, same size. Okay. I don't think so. It's D also. So it's either boy or C. The image that you get is an image that is virtual, upright, and Ali looks much bigger. Virtual, upright, magnified. Only one kind of mirror can give you virtual, upright, and magnified. That is a concave mirror, C. Okay, a concave mirror, C. Yeah. Convex mirror can only give you virtual, upright, diminished. Only virtual, upright, diminished. Concave mirror is the one that can give you many, many different kinds of characteristics. Yeah. Normally their characteristics is similar to convex lens. Okay. I don't know whether I should do this. I feel like doing this might confuse some people. If let's say your F is here, 2F is here, having your object inside here will always give you a virtual upright magnified. Let's say having your object here will always give you real inverted diminish. If your object is here, the image will be real inverted diminish also. Here then is real inverted same, sorry, my bad. Real inverted same size. This is real inverted magnified. Here is virtual upright magnified. And if you have an object at infinity, then you're going to get real inverted diminished. Some people say, oh, teacher, this is the read, wrist, rim, boom, boom. Yeah, this is for concave mirror or convex lens. Putting your object at different place will give you different outcome. Yeah, this one, if you know, then you know. If you don't know, then a bit hard. Yeah. But normally people will just memorize this read, wrist, rim, boom, boom thing. Okay, different position for convex lens, concave mirror will give you different outcome. Okay, number 19. Which of the following situation shows forces are at equilibrium? Aeroplane at constant velocity looks like the answer because constant velocity, same speed, means acceleration is 0. When acceleration is 0, you sub into F equals to ma. A is 0, resultant force is 0. Okay, resultant force 0 meaning equilibrium. Yeah. B, a boy kicks a ball, not very accurate. C, a man is cycling in cycling competition. Okay. A man lift heavy weight. None of that is as straightforward as A. The answer is definitely A is the best answer. Okay. Then number 20. Diagram 13 shows Aina and Aiza fighting over a teddy bear. What is the resultant force that is formed? The answer is 15 and 5 like that. Answer is 5 Newton no, towards Aina. Right? To find resultant force, we would take the bigger force minus the smaller force usually. And then you will just get 5. And it's always towards the guy that is stronger, or in this case, the girl that is stronger. Okay, answer is A, number 20. Some people might also say, teacher, can I do negative 15 plus positive 10? You can. You're going to get negative 5. The negative here just means it's to the left or towards Aina. So got two ways. You just take the bigger force, smaller force. Answer is just 5 towards Aina. Or you can take negative 15 plus 10. You get negative 5. The negative represents to the left or towards Aina. Okay, question 21. The diagram shows a trolley placed in front of a compressed spring, sorry. And in diagram 2 shows the trolley after the spring is released and stop a while at the end of the track. Okay. Which graph shows the relationship between velocity of trolley and the time of the trolley motion? Okay, so it's just a velocity in time graph. Now we carefully look at what is going on. At first, the trolley is not moving. But with the energy, the elastic potential energy of the spring, it is gonna let it fly and have more and more kinetic energy, right? So its kinetic energy is gonna increase and it's gonna increase to a greater speed. By the time we reach here, I believe it is quite fast. So the speed will increase. But when you go up the slope, you will slow down because you are going to gain gravitational potential energy, right? So this is a whole energy situation. At first, elastic potential, then you get more and more kinetic energy, but the higher and higher and higher the slope you go, the less kinetic energy you get because right now you gain more and more gravitational potential energy. Okay, so at first start from 0, then the speed get higher and then decrease again. Answer is boy. Yeah, answer is boy. Quite slow, get faster. When you go up the slope, you will slow down. Okay, uh, 22. Okay, the diagram shows a manometer used to measure gas pressure in a balloon. Okay, what did they say? Which of the following statement is correct about atmospheric pressure and gas pressure? Right. Right now, we can clearly see the balloon is pressing more. Okay, the gas, the pressure of the gas is pressing down on the color water more than the atmospheric pressure. So always for a manometer, I tell my students, you are comparing pressures on both sides. And if I ask you, which pressure do you think is higher? The answer has to be the pressure of gas, because it's pressing down lower a lot more. Okay, pressure of gas is higher than pressure of atmosphere. Okay, let's see what they say lah. Gas pressure in the balloon is less than atmospheric pressure. No, we know gas is more. So A is wrong. Gas pressure in the balloon is greater than atmospheric pressure. That's correct. Okay, it is not equals. Okay, exactly what I said. Gas pressure greater than atmosphere. Gas pressure greater than atmosphere. Okay. Then question 23. Diagram 16 shows the water tank supply system for a water tower to a house tank. What is the pressure that acts on the surface Q? Okay. This one, just make sure that formula is given, by the way. You can look at formula sheet for pressure. P is equals to H rho G. Okay, that's liquid pressure. And they purposely make the pipe curve here and there. Just know that whenever you measure depth, you must always just measure from on top all the way down, straight down. It doesn't matter the shape. The shape of the container can bend here and there. It doesn't matter. Okay, the pressure is just 50 meter times density of water, 1000, times the G value, 9.81. I get 490,500 Pascal. That looks like C as the answer. 4.9 times 10 to the power of 5 Pascal. Okay. Then we move on. Question 24. A gas of constant mass at uniform temperature in a weather balloon has a pressure of 4000 Pascal and 2 meter cube. What is the pressure in the weather balloon when the volume is this? Okay, this looks like one of your gas laws in Form 4. You got pressure and volume. You can call this P1, V1. And then they say what is the pressure when you have this volume. Don't need to worry. You can find the formula in the heat chapter. If you got P and V, you use number 4, lah, the one that is P and V in SPM. Yeah, if you got volume and temperature, then you use the one with volume and temperature. But P and V, P1 V1 equals to P2 V2. Okay, so you got 4,000 Pascal times 2 meter cube. And then P2, I want to find 2.5 meter cube. Final answer is 4,000 times 2 divided by 2.5. Okay. 3,200. Answer is boy. The unit will be in Pascal for sure. Okay. Question 25. The problem of energy loss that occurs during a transmission of electricity from the power generating station to the consumer. Okay, which of the following actions should be taken to solve energy loss problem? Increase current in the cable. This is wrong. When there is more current in the cable, there's going to be more power loss. Because I don't know whether you all know this, the power loss formula is I squared R. Having more current means more power loss. Yeah. Transmit electricity at a low voltage. Answer is also wrong. Actually, during transmission, we will use a step-up transformer. Step-up transformer will help you to increase the voltage. You want to increase the voltage, you want to have a high voltage so that the current will be low, so that the power loss will be less, so that there's less energy loss. Okay, and if you're thinking, teacher, why high voltage means low current is because of P. You think P equals to VI. The power that I produce or the energy that I produce is fixed already. Let's say I generate some electricity. Okay, the electricity that I generated is fixed. The power is fixed. But I use a step-up transformer to increase the voltage, and as a result, I must make sure the current will be less. Okay, high voltage means less current to maintain the same energy that I created. Then the energy is going to flow through the transmission cable now with a very high voltage and low current. It flow. Of course, there's going to be some energy loss, but it will be much less because there is a lot less current. Okay, increase the output voltage is the answer, which is whatever I just mentioned. I want a high voltage from the power generating station. Use cable with small diameter. Confirm wrong because that increases the resistance. Okay, use a thinner cable will increase resistance, which makes it worse. You can find this in your transformer topic, chapter 4.3. Yeah. Okay, question 26. Diagram shows a ping pong ball coated with metallic paint hung between two metal plates by a nylon string. A ping pong ball oscillates between two metal plates connected to an extra high tension. Okay, very classic electric field question. Which change will increase the speed of oscillation of the ping pong ball? Okay, increase length of nylon string. I don't think that helps. The ping pong ball must make sure in the middle, right? You increase the length, then it will be out of the center already. Then the electric field will be weaker. So increase distance between the metal plate. Also wrong. There is a formula actually. The formula is given also, I believe, that you can find in the electricity topic. This one. E equals to V over D. That is related to this. We say, hold on, it's lagging. Okay. We say, if you increase the distance of D, the electric field strength is going to decrease. E stands for electric field strength. which makes sense lah. You put the two plate further apart, of course, the field strength will be weaker. Okay, it won't oscillate faster. Increase the potential difference of extra high tension. Yep, that's right. Because you increase the V, then the electric field strength also increase. Stronger means it will oscillate more. So increase thickness of metal plate. This one also not really accurate. Best answer is C. Okay. Let's look at question 27. They ask, what is the ammeter reading? Okay. This one is testing you on how well do you know your series and parallel circuits. I always say you start with a battery. Start with the battery. This is the positive side of the battery. If you see the wire split into two, that means it starts to be parallel already. When wire split, then only is parallel. If wire never split, don't say parallel. Okay, it is not parallel. But this one clearly is split lah. So you split. This is one. Sorry, this is one branch. This is another branch. Sorry, my throat is quite itchy today. One branch and another branch. Okay, so they will always split and always combine, right? You can clearly see they combine together like this. And then this part right here is after they combine already. So first step is you have to join together the orange color parts because they are in parallel. We're going to use the parallel formula. 1 over R equals to 1 over 2 plus 1 over 2. 1 over 2, 1 over 2, I will get 1. Kita balik, it is still 1. Okay, so this whole thing, it is just 1. Now, if you want me to draw the updated circuit, it looks like this. This is what happened now. Okay, we just found out that this orange color part here is 1 ohm. Then the green color part is right here lah. Do you see the wire never split already now? The whole thing is just one connected wire. Never split meaning all in series. The total resistance now is 1 ohm plus 1 ohm. And the voltage of the battery is 3. According to V equals to IR, 3 volts equals to I times resistance 2. Answer is 3 divided by 2, which is 1.5. Okay, question 27 is donkey. And 1.5. Question 28. Diagram 19 shows an electric circuit. What is the e.m.f of the dry cell in the circuit? Okay, they give you internal resistance, current, the resistance outside here, but they didn't give this. So because they didn't give the value, we assume that it is 0 lah. Yeah. Normally, the thing that has arrow like that is a rheostat. So rheostat, you can usually adjust your resistance. Let's just assume that they adjusted the resistance to be 0. And in SPM, it's like this. If sometimes there's an error, maybe they forget to put value or anything, you still try to do. Okay, you still try to find a way to do it. Don't leave it blank, especially if it's paper 2. Yeah. No value, never mind, we ignore this resistor. We just use this resistor. Information is you got small r, big R, you got I, you want to find E. Formula sheet will tell us there's only one formula you can use to find E. This one. Okay? Or there's only one formula that has internal resistance, small letter R. However, we do not have big letter V. Big letter V, you can always replace it as V is equals to IR. Okay, V equals to IR. Like this. The current is 0.2. The big letter R is 4.5. By the way, big letter R meaning the resistance outside of the battery. The battery is in here. All the resistance outside of the battery is big letter. Inside of the battery is small letter. Okay. Current is 0.2. Small letter r is 4.5. Eh, small letter r is 0.5, not 4.5. My bad. I get an answer that is 1, which is none of A, B, C, D. There was an error in this question. Okay, so during that year, actually this 2023 paper had quite a number of errors, unfortunately. And during the SPM exam, none of the errors were corrected. So like a lot of students, they couldn't do this kind of question, and then they would ask the invigilator to check if there is any error. But you also need to know, paper 1 is just 1 hour 15 minutes. If they want to make correction, they have to make correction for the whole Malaysia, right? So sometimes they might as well just don't correct it, because they scared if I correct for a few schools and then some schools maybe they never received the news, or the correction didn't get there in time, then it's not fair, right? So sometimes they just don't want to correct. Yeah, especially for a paper that is just 1 hour 15 minutes. So this question actually got no answer. Okay, this question actually has no answer. But got some teachers that say that originally they wanted this question to have a current of 1.2 ampere actually. Okay, so if you go and use a value of 1.2 ampere, 1.2 ampere instead of 0.2, so maybe there's a typo here, then the answer would be 6 volts. Then you can get the correct answer. Okay, which is 6, supposed to be 6 lah at first. But unfortunately, this one is just 1 lah. Okay, so what can you do? You tembak lah. If it's paper 1, you just tembak. What can you do? Okay, they have to give this as a bonus question if it's objective. If it's structure, later we will see, because structure question in paper 2 also had some error that is similar to that. I'll let you all know how to deal with it if it's paper 2. But paper 1, you can just tembak something. It will be bonus lah. Yeah, 1 vote. Okay, question 29. The diagram shows set up apparatus to study the effects of magnetic field on a current carrying conductor. The direction of motion of conductor can be determined using Fleming's left-hand rule. If you are one of those students who are not very sure between left and right hand, I always tell my students to think about the 3 letters FBI, right? Your three letters, your force, magnetic field, and current, FBI. If the question is trying to find out force, force is on the left, right? F is on the left. I is on the right. If you're trying to find force, please use left hand. If you're trying to find current, please use right hand. Okay, right now they got magnetic field on a current carrying conductor. Current carrying conductor just means a wire that carries current because there is a battery. That's why this wire is carrying current. Okay, you notice you got magnetic field, you got current carrying wire, you got B and I. These are the 2 things that can help you to find the force. Now, this is how you determine the motion or the force. To find F, it is left hand. Okay, Faraday and Lenz's law, it is part of like you learn together in Fleming's right hand rule, part of electromagnetic induction. So definitely not A and C and D. Okay. Question 30. The diagram shows setup apparatus to study induction current. The movement of magnet in and out of the solenoid will cause the galvanometer needle to deflect left and right. Okay. Which of the following will cause a change in needle deflection of galvanometer? Change the direction of induced. Which of the following cause change in, okay, uh if there is change in direction of induced current, of course it will change the needle deflection. Change in magnitude of induced current, also yes, But I believe they are talking about deflecting left and right because please know that a galvanometer has a zero in the middle. Yeah. And the reason why it will deflect left and right is because the current is coming in from different sides. If current come in from this side, then it will deflect. It will point to the right side, let's say. Yeah? If current is coming in from this way, then the galvanometer is going to deflect this way. Okay. Let me just read C and D also. Change in speed of magnetic movement. Yep, you change the speed. Oh, I think I get change number of turns of coil of solenoid that cuts the magnetic flux. Okay, I understand what the question is talking about already. Because I noticed B, C, D, all of them are trying to increase the current. Okay, while A is trying to change direction of current. And I think when this I think when they say which one cause change in needle deflection, they are referring to change in direction. Actually, this question, this sentence, not so good because when they say change in deflection, it can also mean deflect more or deflect less. So it can still be pointing the same direction, maybe all pointing to the right side, but maybe point more or point less. That one also means change, right? But looking at all the other options, I believe it has to be A, because A is the only one that is changing the direction. The rest is all trying to increase the current. Okay, more current. You move the magnet faster, it will also cut more flux, more current also. You got more turns of solenoid also, it will cut more flux, more current also. Okay, so best answer is A. Sometimes question can sound confusing. You read out all the options, you see what is that one best answer. Or sometimes got two answer, but you have to learn to pick the best one. Okay, yeah? Question 31. The diagram shows the pointer deflection of moving coil emitter. Which of the following statement is correct? Okay. A pair of magnetic force in the opposite direction rotates the current carrying copper coil. Okay, sounds correct to me. A pair of magnetic forces in opposite direction rotates the control spring. No, it is not trying to rotate control spring. It's rotating the copper coil. The purpose of the control spring is to hold the copper core and to hold this middle iron core so that because normally how this works is this is the emitter, so you connect to some current, so you got some current, and then you got magnet, so you got magnetic field. All this is to produce F, to produce force. Okay, normally you want to produce force, you are trying to create a motor lah. A motor is like a fan like that. A fan is an example of motor where the blade will keep on spinning, spinning, spinning one. But for ammeter needle, you don't want it to keep spinning, right? You want it to spin to a value and then stop. So how to make sure it spin to a value and stop and don't keep spinning, spinning like a fan? You use the spring to control it. You use the spring to pull it. If got more force, the spring will allow it to go further. If got less force, the spring will allow it to not go so far. That gives you different value. Okay, and then C, a permanent magnet rotates in a current carrying copper coil. Permanent magnet rotate. No, the mag the magnet is not rotating. The coil is the one rotating. Permanent magnet rotates the current carrying copper coil. No. A permanent magnet rotates the control spring. Also no. The magnet is not the thing that rotates. It is the catapult field that rotates. It is the interaction between magnet also got magnetic field. Wire also got magnetic field. They interact with one another. They produce a force. Best answer is A. How come opposite direction? It's because you think like this. Normally, a simple motor looks like this. Right? When the coil wants to rotate in the center, there's gonna be one force, okay, because current go in one side, current come out one side, and then there's gonna be be one force pointing up, one force pointing down, let's say. Then it keeps on spinning. Maybe one force point down, one force point up. This is what we mean by force opposite direction and make it rotate. Same thing here lah. One side want to rotate this way, another side want to rotate that way. So it's opposite direction. That's why it will want to spin. Okay, so that it gives you a value, let's say. Question 32. There's 4 electronic components. Which of the following components can be used as an amplifier? Normally, we call it a current amplifier. And you learn this in a transistor. That is the function of a transistor. One of the function of a transistor. Now, they give you 4 pictures like that. A lot of students will be thinking, teacher, how would I know which one is a transistor? Very simple. The transistor is the one that has 3 terminals. The one that has 3 legs. Okay, so only P and Q can be the possible answer. Answer is A. If it's R and S, it's impossible that it is called transistor. Yeah, because R and S only got 2 legs. This should be a diode. Okay, this should be a diode. P and Q, they are transistors, most likely. So answer is A. This one quite key, but yeah. Question 33. This is also a transistor. You see, transistor got 3 terminals on 1, 2, 3. Got 3 legs on. Okay, this is the structure and symbol of a transistor. Which of the following is correct for X, Y, Z? X, Y, Z. X is C, Y is B, and Z is E. It is it is always base in the middle, and then between the arrow here is always between base and emitter one. Okay, I always joke and tell my students, because my name is Brian, right? I always joke and tell my student, oh, this is choose Brian every time. Yeah, CBE, collector, base, and emitter. Collector, base, emitter. Answers boy. Okay. And sometimes if they want to be kibat or be tricky, they can also terbalik this whole picture. But remember, the arrow part is only the part between base and emitter. Okay, and it's the same, whether is it PNP or NPN transistor, is always CBE. It doesn't change. Okay, question 34. Diagram shows a light control switch circuit. Which of the following combination is correct to light up the bulb at night? Okay. Here's the thing. Lighting up bulb at night using a LDR, you must remember that if it's nighttime, LDR will have the resistance will increase. We have higher resistance. Okay. If it's cold time, if I use a thermistor, resistance also increase. So I always tell my students, you all remember this, that whenever it's cold and nighttime, your LDR or your thermistor, the resistance will go up. Okay, and what is the opposite of a cold and night? Or it's day, and also, opposite of cold is hot, and then opposite of night is day. All this will make the the thermistor or the LDR to reduce in resistance. Okay, so right now we are not talking about the hot and cold one. We are talking about the nighttime one. And nighttime resistance here increase. When resistance here increases, the voltage here increases. This is what you call the base circuit, the base voltage. Okay, it means that the base voltage increase. Whenever the base voltage increases, this is the simplest knowledge you must know for a transistor automatic switch circuit, that your goal is to always have the base voltage higher or increase so that base current flows. Whenever base current flows, transistor will turn on, will activate. When it turns on, then only the collector current will start to flow. If it doesn't turn on, that means if there is no base, then there is no collector. Okay, so answer is that both also will increase. IC, IB both also increase. Collector current, base current both also will increase, then it will light up everything. Answer is A. Can? Okay, so if what happens if the base is too low, the voltage? Then base current will not flow, transistor will not turn on, collector current also will not flow. Bulb M also won't light up. Okay? Your goal is always this. Yeah, and always remember resistance higher always means voltage is going to be higher because of V equals to IR. Voltage higher resistance. These two they are proportional to each other because current is constant. I don't know whether you all know that. Okay, actually there's a lot more to it lah. Like I'm trying to explain just one objective question. These two guys they are in series, Series circuit current is the same. But the voltage here will share between here and here. Right? So whoever has more resistance will always get a bigger share of voltage eventually. Because both of them, they have the same current. That's why I say, if this guy, the resistance increase, the voltage will always increase. If the resistance drop, voltage will always drop. Remember that. Okay. Question 35. Which of the following statement describes the use of graphite core in nuclear reactors? Graphite is usually used as a moderator to slow down fast moving neutrons. I always tell my students when I teach them this, I will tell them this is what I call a slow mo graph. It doesn't make sense, I know, but somehow they just remember it very well. Slow mo graph. You have to read from the back. Slow mo graph. Okay, graphite moderator is always to slow down. The best answer is boy. To absorb neutrons, this is the job of a control rod. Okay, to increase rate of fission, this one is not because we are trying to the moderator and the control rod, the job is to control the rate of reaction. To remove heat of reaction also wrong. Yeah, answer is boy. 35 is boy. Okay, 36. Which of the following radioisotope is suitable to detect leakage of underground pipe? 60 seconds too short. 60 seconds, that means every 60 seconds, the number of radioisotope P will decay by half. That means when it decay by half, that means it becomes stable already. And when it's stable, there's going to be less radiation that is going to be emitted. 12 months is also too long. 6 days is also quite long. I think the best answer is B. Okay, so how it works is, normally for an underground pipe, you put a few drops of radioisotope Q in the water source, maybe in the water tank. Then the water is going to flow to the pipe. At a point where the pipe is leaking, maybe because there's water, there's some botcher point here. Okay, so this is water and then the water flow up. But this is underground. How to detect this leakage is because inside the water there is a little bit of radioisotope and it's maybe going to emit some radiation at this point here. Maybe it could be an alpha radiation or beta or gamma radiation, either one. Yeah, 12 hours is good. It gives us enough time to find where is the leakage point. And also, 12 hours is not too long in a way that it will become stable on its own pretty fast. Every 12 hours, the radioactivity will cut down by half. So become less radioactive by half, less radioactive by half. That is what we call as half-life. Not too long, not too short. Okay, if it's too long, it will be quite dangerous because you keep on getting exposed to a lot of radiation. Yeah, imagine you are washing hand in the toilet and then got radiation coming out from the water like that. Yeah. Okay, 37. The equation below shows radioactive decay. Which of the following represents Q? Q has to be a beta particle, I believe. Looking at this number, because you are trying to balance the equation, right here you can only put two possible things. Number one is helium nucleus. Number two is an electron. Okay, helium nucleus is your alpha particle. Electron is your beta particle. The gamma ray, the gamma ray got nothing on. You don't need to add anything. Okay, so because gamma ray is just a pulse of energy, just a wave. And you see, if you go and put this right here, it will help you to balance the proton and the nucleon number, right? The nucleon number is 90 equals to 90 plus 0. And then proton number is 38 equals to 39 minus 1. Answer is B. Okay, question 38. Which of the following is the unit of mass of atoms and subatomic particles? AMU, atomic mass unit. Yeah, you can even find in the formula sheet, they give you one atomic mass unit equals to how many kg. Okay, we use atomic mass unit for very small mass objects like atoms and subatomic particles. Okay, question 39. Diagram 26 shows a piece of lithium metal illuminated with light. No photoelectrons are emitted. Which statement is correct? You shine light, but don't have electron coming out. No photoelectric effect. Okay, the intensity of light is insufficient. Not very accurate. Intensity is the brightness. It does not affect whether or not you can emit electrons. Duration of lithium exposed to the light is short. Also wrong. The work function of lithium is lower than the energy of one light photon. Also wrong. Because if your work function is lower than the energy, or that means the energy is higher than the work function. If the energy of your photon, the energy of your light photon is higher than the work function, means minimum energy to emit electron. If it's higher than the minimum value, then the electrons is going to come out, right? It will not come out. So answer has to be donkey because the frequency of your light is too low, lower than the threshold frequency. Threshold frequency means the minimum frequency. F must be bigger than FO. Threshold is FO. That's how we label it. For you to have photoelectric effect. These are the two criteria for photoelectric effect to occur. This is one of the basic things for photoelectric effect. The energy must be bigger than the work function, or the frequency must be higher than the threshold frequency. Okay. Number 40. Which of the following statements states quantum theory of Max Planck and Albert Einstein? Photon energy is inversely proportional to frequency. That's wrong. Energy is directly proportional to frequency. Okay, you can find this formula in formula sheet also. Discrete energy packets and not continuous energy. This is the idea of Max Planck. By the way, they spell Max Planck wrong. It's Planck. They forgot the C. Yeah, but it is not part of Albert Einstein. So let's see. It's not wrong lah, B, but it's maybe not the best answer. Let's see. For C, a photon is a quantum of light energy that cannot be transferred. Photon can be transferred. Yeah, photon can be transferred, not cannot be transferred. So C is wrong. D, A photon is a light energy that exists in the form of an energy packet. Okay, B and D are both correct statements, but the best answer is donkey. Photon is discovered by Einstein, and energy packet is discovered by Max Planck. So this is a statement that has two together, quantum theory of Max Planck as well as Albert Einstein, like together, this one statement. Okay, B is just Max Planck alone only. Yeah, answer, this one a bit tricky Question 40, answer is donkey. Okay, and there you go. This is the end of our paper one, right? All the best with your SPM. This is 2023 paper one, done. We'll stop here first.